see you put your new transmission man right to work on the Torqueflite jobs.
Sure did, Tech. Dick shows a lot of promise as a transmission specialist, and he's not afraid to ask questions. In fact, it looks like there's another question coming up right now.
That mileage complaint on the 65 model turned out to be a simple case of the wrong speedometer gear, Norm.
Thanks, Dick. Mr. Norton will be glad to hear that. Think you're ready to tackle a 66 Torqueflite?
Well, I understand there have been a lot of changes in this year's Torqueflite, and I haven't been inside one yet, but a guy has to start sometime.
That's a healthy attitude, Dick. But I have a better idea. Why don't we run through the changes in the new Torqueflite so you won't have to fly blind? I'm sure Norm can straighten things out, and I'll try to help keep him out of trouble.
Good idea, Tech, and thanks for the confidence. There are a number of differences in the hydraulic system, clutches, and linkages that a technician will have to know about before tackling the 66 models. I think we can cover them all in a short time, so let's get started.
The procedures for disassembly and assembly are well covered in your service manual, so there's no need to repeat them here.
Okay, Tech. The most important difference between the 65 and 66 Torqueflites is the elimination of the rear pump. A number of other components were affected by this change in design. As you know, the primary reason for having a rear pump was to provide pressure for push starting the car. But push starts have gone out of style on our cars, and for very good reason. Our more efficient ignition systems, coupled with the alternator, have just about eliminated any need for push starting. If a car does need help to get started, it's much smarter to use jumper cables than to tangle bumpers.
Now, if you're going to tow a 66 with Torqueflite for more than 15 miles, be sure to either pick up the back of the car or disconnect the propeller shaft. For shorter distances, keep the towing speed under 30 miles an hour. Otherwise, you'll damage the transmission. Here's why. Since there is no rear pump, towing the car without the engine running would subject the gear train to rotation without any lubrication. The output shaft support will be the first part to fail.
That's one I'll be sure to remember, Tech. Now, how about some of the other changes caused by rear pump elimination, Norm?
Coming right at you, Dick. First of all, there are no more pump check valves in the transmission. As you know, the check valves prevented each of the two pumps from bleeding out through the other. Since all the transmission oil flow is provided by the front pump, the check valves are no longer needed. Here's another internal change brought about by rear pump elimination. With the elimination of the rear pump, the governor is fed regulated line pressure. In previous models, the governor was fed directly from the rear pump.
There's a new spring in the governor valve, too, Dick. The spring's strength was lowered to take full advantage of engine torque. Maybe you better explain it, Norm.
Okay, Tech. To properly match car speed to governor pressure, it was necessary to install a lighter spring in the governor. This resulted in higher full-throttle upshift speeds, which is desirable. But the higher upshift speeds also meant higher full-throttle kickdown speeds, which is not desirable. Especially undesirable is a full-throttle kickdown from direct to breakaway at speeds above 40 miles an hour. So, the 1-2 shift valve was redesigned to lower the maximum 3-to-1 kickdown speed. So you'll get a 3-to-1 kickdown at speeds below 30 miles an hour, but you won't get a harsh 3-to-1 above that speed.
This change was made in both the A727 and the A904 Torqueflites, and it was made very early in production, so you won't find many of the old-type valves in 66 models.
Okay, Tech, but what's the difference between the valves?
Well, first of all, you know that the end of the valve that's toward the governor plug is subject to throttle pressure when the kickdown valve is shifted. Since there's equal pressure on the other end of the valve, the hydraulic forces on the valve are balanced out. The throttle pressure acts against the governor plug, moving it against governor pressure, and the shift valve spring moves the valve over into the first gear position. The revised 1-2 shift valve has an extra groove cut into the governor plug end, and a small hole through the end of the valve into the groove. Here's what the groove and hole do for us. When the throttle pressure is directed from the kickdown valve to the 1-2 shift valve and governor plug, some of the fluid bleeds through the hole and into the groove, which is aligned with an opening back to the sump. This bleeding off of fluid limits the buildup of pressure between the valve and governor plug. During this period, the 2-3 shift valve will move into second position. Then, if the car speed decreases to the point where a kickdown to breakaway is desirable, governor pressure will have fallen low enough to permit movement of the 1-2 valve.
There's another orifice in this circuit in conjunction with a redesigned valve. It's located in the separator plate between the valve body and the transfer plate. The separator plate and the new valve are both interchangeable with the early type parts.
Right, Tech. And here's something to be careful about. Anytime you have a valve body apart, be extra careful how you handle the valves. You don't want to get any nicks or scratches in them, so don't just dump them into a basket for cleaning. Another thing, when you're installing the valve body in the transmission, use a torque wrench. Otherwise, you'll distort some of the passages and bind the valves. Or if the screws aren't tight enough, high pressures will cause a leak. Either way, you'll wind up with an erratic shift pattern.
Here's another good place for the torque wrench. Before you install a valve body, loosen all the transfer plate attaching screws and retighten them at 28 inch-pounds.
Good idea, Tech.
The other day, I heard you mention something about a venting problem on the governor. Now, how about that story?
That's another early production problem, Dick. But we caught it early, so you won't see many of them. I'm sure Norm has the dope. How about it, Norm?
You may run into a transmission that doesn't downshift properly at closed throttle, or it might not downshift at all. If you do, it could be caused by a restricted governor vent, or too much clearance between the governor support and the output shaft. If the vent slot in the governor body is restricted, there may be a residual pressure buildup in the governor, holding the valve open. Or, if there is too much clearance between the governor support and the output shaft, line pressure might leak into the governor body. If it does, you'll get upshifts at low speed and probably no downshifts at all. Either one of these conditions can be corrected by drilling a 1/8 inch vent hole in the governor body.
Be sure to take the governor out of the transmission before you drill the hole. You sure don't need any chips inside the transmission.
That's for sure, Tech. While we're at the back of the transmission, let's talk about another possible cause of shifting problems. It's the output shaft support. The support is a very tight fit in the transmission case. In fact, if you have to remove the support, it has to be driven out of the case. When you're installing the support, be sure to shrink it before you drive it in. You can cool it with dry ice or the freezing compartment of a refrigerator. Just make sure you cool it. If you try to install the support without shrinking at first, you'll distort the case and the support and develop a leak in the governor feed passage, or the passage from the governor to the shift valves. If either passage leaks, the transmission won't shift properly.
Just be sure to shrink the support. Don't try to expand the case, or you'll warp it out of shape. Since we can't expand this record either, someone better turn it over.
While we're on the subject of output shafts, there's a change in the sliding yoke. Early production models had a grooved neoprene seal on the output shaft, which prevented transmission fluid from mixing with the multi-mileage grease in the yoke. The yoke had a vent hole in the outer end to prevent any of the multi-mileage lube from being forced past the seal and into the transmission fluid. On the later 66 models, the yoke splines are lubricated with transmission fluid, so the grooved seal has been eliminated. The pocket at the rear of the yoke is vented along the output shaft by leaving out one of the splines in the yoke. The new yoke doesn't have a vent hole at the rear, so be sure you don't use a non-vented yoke with a grooved seal or a vented yoke without the seal.
As long as we're at the rear of the transmission, let's talk about the new speedometer gear adapter and some of the servicing precautions.
Good idea, Tech. One of the major causes of trouble with the speedometer gear adapter is dirt. Make sure there is no dirt under the adapter seat when you're installing it. A little bit of dirt there can throw the pinion out of alignment. It doesn't take much misalignment to cause gear failure or an oil leak around the O-ring.
Here's something to think about when you're looking for an oil leak in this area. Sometimes a leak at the O-ring will appear to be coming from the pinion seal inside the cable housing coupling. Just keep in mind that if it's a pinion seal leak, you probably won't see it until the coupling is unscrewed.
That's right, Tech. Of course, the pinion seal won't leak if the technician uses the special installing tool. The tool sets the seal at the exact specified depth. Another important thing about the adapter is the retainer. Be sure the retainer tangs are in the slots. If the adapter is turned even slightly out of the correct position, the pinion won't mesh with the drive gear properly and will soon fail.
I've noticed that the clutch plates in the 66 models are mighty thin. Looks like they can't last very long. How about it?
You better straighten that one out pretty fast, Norm.
I sure will, Tech. We're using a new material in our clutch plates this year. Actually, the plates last much longer, even though they're thinner than before, and they have improved friction characteristics. The kickdown band also uses the new material, so you may never have to adjust the band.
Eventually, all the bands and clutches will use this new material. Now, why don't you go over the new shift linkages, Norm? They're quite a bit simpler, with the rods replacing the two cables.
They sure are, Tech. For one thing, there are no detents at the lower end of the steering column. Instead, the valve body detents have been made much stiffer than on previous models. Incidentally, that's something to watch for when you disassemble a valve body. The spring behind that detent ball is pretty powerful, so be sure to use the detent spring retaining tool. On all models, the linkage is adjusted with the selector lever in park position and the valve body control lever in the last detent toward the rear of the transmission.
On column shift models, be sure to have someone hold the selector lever down against the park gate while you're adjusting the linkage. Tell them why, Norm.
Okay, Tech. The column shift gate doesn't have a stop to prevent the selector lever from moving beyond the park position when the adjusting swivel is loosened. So, if the selector lever isn't held against the park gate when the linkage is set, parking pawl operation may be erratic. This adjustment also determines manual valve position for all other selector lever positions. So, erratic pawl operation could also mean that the valve will be slightly off location, especially in drive and reverse position. If the valve is off location and the hydraulic passages are not opened completely, it's possible to get partial or at least very slow clutch or band application. Over a period of time, slow or partial applications will burn the clutch or band friction surfaces.
Don't forget the neutral starting switch either. If the control lever is out of position, the tangs won't contact the switch in park and neutral positions, and the engine won't start.
Thanks, Tech. I hadn't thought about that. But where are the adjustments made on these new linkages?
There are two different methods of adjustment, Dick. On all except Valiant and Dart console models, there's a swivel clamp at the shift linkage torque rod. You merely loosen the clamp, set the control lever in neutral, hold the selector lever in park, and tighten the clamp. Valiant and Dart consoles have an adjusting lever at the lower end of the shift linkage torque shaft instead of the swivel clamp. On all console models, the gating is controlled by the push button in the top of the selector lever. To adjust the button, place the lever in neutral position and loosen the set screw in the knob. Turn the button in or out until the serrations are 1/32 of an inch above the shift knob.
I understand there's some confusion among technicians about how the new parking lock operates. Maybe you can clue us in on that, Norm.
That I can, Tech. The new parking lock assembly consists of a rod, a spring-loaded locking lever, and a parking lock gear. The front of the rod is attached to the manual valve control lever through an over-travel spring arrangement. The rear of the rod has a knob on it, which for explanation purposes I'll call a cam. This cam is what actually pushes the locking lever into the gear. Here's how it works. As long as the transmission selector lever is in any position other than park, the cam on the rod is to the rear of the locking lever and doesn't touch the lever at all. When the selector lever is placed in park, the cam moves forward, pushing the tooth on the locking lever into contact with the gear. This locks up the transmission output shaft.
Supposing the tooth on the lever lands on the top of one of the gear teeth instead of in between two teeth.
Well, that's where the over-travel spring comes into the act, Dick.
Right, Tech. The rod actually goes through a hole in the attaching swivel at the manual valve control lever. On the front end of the rod is an over-travel spring and a spring retainer. If the tooth on the locking lever hits the top of a gear tooth, the cam can't move the lever